Given a binary tree, print the left view of it. Welcome everybody to another mock interview with Exponent. Today we have Roshan with us. Roshan, would you like to introduce yourself before we get started?
Absolutely. So, hi everyone. My name is Roshan. I currently work as a senior software engineer at Amazon, and I have like 5 years of experience working with multiple firms, including Deloitte, and now working as a engineer at Amazon. So we operate the team which I work here at Amazon, we operate at a massive scale. Our team is responsible for generating tracking IDs for each and every package which is bought by our customers in this planet Earth. So we operate at a massive scale, and especially during those times when we are at COVID situation, and everyone is trying to purchase products online, staying at their homes and purchasing products, be it grocery items or be it anything for that matter, right? So that's what, like currently we are at, we are operating at a peak scale. But yeah, having said that, I have a huge, I have interest in solving problems and helping people who want to grow in their career, be it cracking coding interviews and stuff like that. So yeah, that's all about me, and I hope that one day I will create a impact which is going to help people in this earth.
That sounds great. Thank you so much, Roshan. Let's dive right into it. So the question for you today, Roshan, is given a binary tree, print the left view of it. And the left view is the set of nodes that are visible when the tree is looked at from the left side.
Mm-hmm. Okay. Okay, got it. So can you just explain me what that left view means? I'm aware of binary tree.
Mm-hmm.
I know the tree data structure, but can you please help me understand what is the left view?
Sounds good. So let's say that this is your binary tree, okay? This is your root node. These are the two leaves, all right? Now, I don't know which is your left, but let's say this is defined as left. All right. If we look at the tree from this angle, from the left side, what are the nodes that we're going to see? And bear in mind that if there are two nodes on this level, you're not going to be seeing this one because it's going to be blocked by the thing in front of it. So that's what a left view means.
Okay. So say suppose if I have a root node and then one and two as, sorry, if one is the root node and two and three is its child node, so I have to print one and two.
Yes.
Say suppose if I only had one and then three, but no two, then
Mm-hmm.
my output should be one and three. Is that correct?
Exactly. That's exactly correct. Yes.
Okay. Wow. Awesome. Okay. So I'm just thinking of how I could solve this problem. First of all, I am pretty much aware that um, any binary, binary tree related problem, they have three types of traversals. One is in order, pre-order, and post-order. So I'm just thinking of how I would be approaching this problem, right? Before that, I'm
Mm-hmm.
just also wondering, yeah, I have some follow-up questions. What can we have an empty tree? If that's the case, then what should be the output? Like for example, if I were to just pass null as the root node, so should I simply return null or should I
Yes.
print minus? Okay.
If your tree is null, return null.
Okay, so that's something which I wanted to ask. And is this a regular binary tree? I think even if it's a binary tree or binary search tree, I think the output shouldn't matter, right?
Yes.
Okay,
Yeah.
so I think, mm, yeah, I think I don't have any other clarifying questions. I think I'm pretty good with the question. Okay, so basically I'm gonna print one here. So this is the root node, right? So what I know already is we have like in order, then we have pre-order, and then we have post order. But however, since our use case falls more into pre-order where we print the root node first, followed by the left tree and the left subtree and the right subtree, right? So I'm going to use pre-order traversal here.
Mm-hmm.
The reason being that I want to give more priority to the root node. So I'm going to start with root first, followed by left node, followed by root right node, right? So that's going to be my um, strategy. However, I don't want to print the right node. Like basically, I want to ensure that at each level, basically, like for example, this is level one, okay, and then we have like, yep, sorry, yep, this is level two. What I need to ensure is if I have printed the first node at level one, I don't want to print any other nodes. Or in other words, like say suppose if I go to level two, if I've already printed a node at level two, I don't want to go to, I don't want to print the another node, right? So for example, say suppose if in the third level we had yeah, only six as the right
Mm-hmm.
subtree, then this would be level three. And since two doesn't have any right, um, doesn't have left and right subtree, and three only has the right subtree, and that's the first node at level three, I'm gonna print this. So then my output would look something like 1, 2, and 6.
Mm-hmm.
So in simple words, I'm just gonna find the I'm gonna go at each level and see the first node. So yeah, that's what
Yep.
I'm thinking.
Okay, sounds good.
Okay. So yeah, let's first create some nodes here. I'm gonna say in data, and every node will have left and um, right child. And let's add a constructor in here. Say this dot data is equal to data, and I'm just gonna initialize the left and right um, child to null.
Mm-hmm.
Okay, so this is just a signature. I'm just gonna make this public. Okay, so so let's create a sample tree. So node root is equal to new node of one, and then I'm gonna say root dot left is equal to new node of two. Just copy this and put it here, and say
Mm-hmm.
root dot right is equal to three. So basically, I'm just trying to create a replica of this one, 2, 3, and later on we will extend it to six as well. Okay.
Sounds good.
So now let's create a list of integer, and we say that result is equal to a new array list of. I'm going to store all my left view in the result, and I'm going to finally print it. Okay.
Okay.
So um, let's create this. Okay. So this this left view will take the root as the input, and
Mm-hmm.
it's oh, by the way, it will also take a list which will contain the result. And yeah, so once we, let me create an instance of this instance dot left view of. I'm going to pass in two parameters. One would be the root, for which we have to print the left, which we have to see the left view and store them in this array list, which is going to be result.
Mm-hmm.
And once we have the result, we just want to print it. So okay. So just to summarize this code, basically we have created a tree here, and we are creating the result which will store the result of the left view. So for example, I want to, like, if I pass 1, 2, and 3 as the input, I want to store 1 and 2 in my list, and then finally print this list. That's it,
Mm-hmm.
right? And then yeah, that's all I have done. And this is the signature. Basically this left view is taking like taking two parameters. One is the root of the tree and the result where it's going to store it.
Yep.
Yep. Okay. So if the tree is empty, we just want to return it. So we'll start with the base condition. If like root is null, we simply return it, because we don't want to do anything with it, because like if the list is if the root is null, then we simply return an empty result. So
Hmm.
this will anyways contain the answer because this has already been initialized as empty result, right? So yeah. Okay, now what we want to do is if we find also want to calculate the level, right? um, okay, so my root would be at level 0, I guess. Yeah, so I also want to have something called level where where when I make a recursive call, I keep incrementing the level
Hmm.
and see uh, if I have reached a level and it's first node. So what I'm going to do is I'm going to say my root is at level 0.
Okay.
So uh, so whenever I see a node which is at a level and it has not been printed yet, so I want to add that element to my list. So
Hmm.
in this case it would be 1. Now I'm thinking about the next case where if so level plus 1, which would be 1. So let's say this is okay, let's do one thing. Let's take the root as level 1 itself. Yeah, so this is level 1. So 1 wouldn't have been printed, so I need to add that node to my result and then increment the level, so it would be level 2 now.
Okay.
Then I want to see if we have already printed any element at level 2. So
Hmm.
since we wouldn't have printed, we want to add uh, 2 to the result. But when we reach a point 3, we again see if we have already printed any node at level 2, and since we have
Hmm.
already printed it, we don't want to include this element, right?
Yeah.
So let's do one more thing. Let's basically we also want to have some uh, max reached so far, and let's initialize this somewhere here, max level, and let's initialize this to 0 because um, 1 is greater than 0 and we want to print the root. Okay, so we want to print the 0. Why 0? Because let's say we are at max level 0. So if this level is greater than max level, so we know that we have reached a point where we want to add the element to the list, basically
Hmm.
result dot add of that uh, root dot data something. So then when my level is 2 and my max level is also like my max level would be 1. So since 2 is greater than 1, I can add 2 here. But for 3, since we have already incremented max level, so 2 greater than 2 would be false, and then I will not have to add root dot data. So
Hmm.
yeah, I'm just going to say if max level is less than level, then let's say result dot add of root dot data, and I'm going to say max level is equal to level, so that I don't end up adding 3.
Hmm.
And then I'm going to just print this root dot left and then level plus 1 because I'm just incrementing at every recursion, and the result is going to be the same. And same thing I'm going to repeat for the right subtree. Yeah, this one.
Hmm.
So if okay, so I'm just doing a dry run of this approach. So we pass 1 here, so level. Okay, so in the first iteration it would be 0 less than 1. I'm gonna add uh, root dot data to my result, which would be 1, and then I'm gonna say max level is equal to level. So now max level is 1. Okay, root dot left. So we come here and level plus 1. So level plus 1 would be 2. So 1 less than 2 is true, and I'm gonna add root dot data, so 2, right? And then so if then again root dot left would be null, so it will return, and then root dot right, which is again null, so it would return,
Hmm.
and then it would check the right subtree, which is this one now. So root dot right, it would come here and check max level would be 2 by 2 by this time because we have initialized here and not inside this function. So yeah, so 2 less than 2, right? Because 3 is also at level 2. So 2 less than 2 is condition false. So we will not be adding the result. So
Mm-hmm.
finally, yeah, again, it will check the left subtree and right subtree of 3, which would be null and null. And finally, it will return the result, which we are printing here.
Okay.
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 So let's try this out. I hope this works. But yeah. Okay. So if I run this code, oh, line 19 is not a statement. Hmm.
It's just there's a comma there. Yeah.
Okay. Oh, I didn't wanted to print a line. I just wanted to say, okay. Okay, so let's further extend this code a bit. Like, I'm gonna say, um, three, three's right child to be 6. So root dot right is equal to 6, and I'm expecting the output to be 1, 2,
Mm-hmm.
and 6.
Okay.
Okay, so yeah. Oh, there you go. Yeah. So yeah,
Great.
I think I also want to just check one more thing. Instead of, if I just pass a null here,
Uh-huh.
I just want to see if it's still working. Okay. I mean, it's not printing anything basically. Yeah.
Empty list. Yeah. Okay, that's great. So what's the complexity of this solution?
Um, Basically, it's the, in the worst case, we are iterating over all the nodes of the tree. So O of n, where n is
Mm-hmm.
the number of nodes in the tree. So yeah.
Got it.
And we are not using any extra space except for the result. Like if we were to ignore this list and simply print the answer here, that would still work, right? Because this result is basically containing the result, like, the elements that we want to print. Like in case if we want to, uh, remove it altogether,
Hmm.
we can simply print it here. So we don't need this extra space as well.
Got it. Yeah, that would be good space optimization. So is there any optimization that you can make to the time complexity of this algorithm?
I understand. So basically, why do I have to visit the right subtree
Mm.
if I have already found a node which has added in the list? So do you understand what I mean? So
Yeah.
say suppose we are at level 1,
Mm-hmm.
right? And if I have encountered a node which has already been added to this result set,
Mm-hmm.
then I don't even have to visit 3. Oh no,
Yeah.
I still have to do that. The reason being, if I don't visit it, I will not be able to encounter 6, because the reason why I'm able to encounter 6 is because I have visited 3. Now think,
Yes.
if I
Yeah.
don't do that, I mean, my solution would assume that there was only 1 and 2, but there was no nodes at level 3 at all. So yeah, I
Mm.
wouldn't do that. Yeah. Okay, yeah, but so yeah, I don't have any um, time optimization here. Yep.
Got it. Okay. And then maybe we should implement the space optimization that you mentioned.
What we could do here is just remove this result because we don't need it here,
Mm-hmm.
and just print it here. So we say like just this thing, system.out.print, and then just add root.data plus some spaces in here, and then we don't pass. Yeah, we can remove this altogether, and we just say instance dot left view off, and now just pass the root and the level,
Mm-hmm.
which is 1,
Okay.
and we can remove this result as well,
Mm-hmm.
and some more, so we don't need this instance anymore. Okay, so yeah, so we don't need that extra space now. We just print
Mm-hmm.
it as and when we encounter. So now the output should still remain the same. Oh no, left view result. Oh, okay, in the recursive call also I will have to remove the result. Yeah. Okay.
Yes. Nice. Let's add a little extra spice to the question. So now, what if I ask you, I'd like you to print the left view of the tree as well as, um, so the left view and the right view. So you're printing basically an outline of the tree.
Yeah, right. So the left view is 1 and 2. So if I were to print the right view of the same tree, it would be 1, 3, and 6.
Mm-hmm. And what if we want the outline of the tree? Let's say we want it to print like 2, 1, 3, 6. There could be a
2.
bunch of stuff in the middle, but we don't really want that.
Hmm. Okay. I think outline of the tree. So for example, if we were to have 4 in here and
Mm.
5 in here, okay, let's add some spacing. Okay, so 1, 2, 3, 5, 7, and then 8. Okay, now the output that you're expecting is 4, 2, 1, 3, 8.
That's right.
Okay, okay. Hmm. But so one question here, like 5 and 7 is also an outline, right? Like, do you understand what I mean?
Yes, it's an outline of like a subtree of the main one.
Yeah. So okay. So I think I understand where you're getting with this. Basically, if we were to have something like this, like one moment, can I move this a bit? Okay, now if we had some nodes in here like 9. Okay, let me some. So 9 and then 1 and then 2. So, okay, let me just put it this way. So 1, 2, 3, 4, 5, 6, 7, 8 again. Okay, now 4 has some more left and right subtree. So 1 and 2, then 3
Mm-hmm.
and 4 for 5. For 7 we have 5 and 6, and for 8 7 8. Now the output would be 1. Sorry, yeah, starting from the leftmost
Mm-hmm.
node. So 1, 4, 2, 1, 3, 8, and 8.
Yes.
Or do we also want to print the last line? All I just wanted to know is, are you interested in the uh,
In the bottom edge of the triangle? No, not interested in the bottom edge of the triangle.
okay, okay. So basically this seems more to me like a combination of left view
Hmm.
and the right view, excluding the root.
Excluding which root?
Okay, excluding which root? Good question. So basically the root which is here. So I mean,
Okay.
what I mean by that is, I don't want to print something like 1, 4, 2, 1, and then 1, and then 3, 8, 8, right? Because uh, if I'm printing from the left view, I just want to ensure that 1 is printed only once. Or if I'm printing it from the right view, I just want it to ensure that we have root only once. I don't want this. Do you
Yes.
understand what I mean? Yeah.
Yes.
Hmm.
So what would can you just type out what the output would be for this tree that you've drawn?
No, I mean same thing except that. Yeah.
Got it. Yes. Yeah.
Hmm. Okay. So I think I can just make some changes here
Uh-huh.
to print this. Okay. What we have, like if we were to leave this solution as it is, so what would we get so far? So we would get this part, right? Okay. By the way, we are printing it. So this particular solution is printing the element from the root, right?
Mm-hmm.
So we are printing 1, 2, 4, and 1, but we
Mm.
want it to be printed from the left. I mean, starting from here and then go all the way to the top.
Yes.
Okay, so let's first change that a bit.
Okay.
So I'm just gonna move this code here. And okay, now why did we do that? Because we wanna go all the way down. So this root dot left will, keep it will keep recursively going all the way down until
Mm-hmm.
it reaches this point. and then we want to do this calculation that we did earlier,
Yep.
right? And then print
Okay.
it. So let me just see for the input that I passed. So it was 1, 2, 3, and 6. Oh,
Mm-hmm.
I just delete it? Okay, let me just draw this again. So we had like 1, and then we had 2, and then 3, and
Mm-hmm.
then 6. So now the output would be 2. Okay, let me think. Go all the way. Okay, so 2, 1, and 6. Yeah, so 2, 1, and 6. Yeah, so that's what I'm expecting. So let's see. 2 and 6. Why didn't I get 1? Max level. Oh, okay, because this is this would be 1. Okay, because I'm not. Okay, by the way, I still don't need it, because as far as this problem is concerned, I don't want this root to be printed, because I will anyways take care of it in the middle. So that
Yeah.
should be fine. Yeah. So
Okay.
2 and 6. So 2 here and 6 here. Okay. So however, I'm just wondering one more thing. Do we really need to consider the left view of this one, because this will anyways be taken care by the right view?
Mm.
So, so we start. So if okay, for this input, it would be like 2, 1, 3, and 6, right?
Yes.
Right. Okay. So I don't have to worry about the right view anymore, because this will anyways be taken care by the right view method. So like something
Mm.
similar. So we just create another method in here.
Mm-hmm.
Say void of right view, and just change right view. Yep. And then root dot right. Hmm. So so root dot left would print this, and root dot right this. I'm just wondering about the max level now. So max
Mm.
level is 0. I want to ensure that before I make a call to left view and right view, max level is initialized to 0 again. Hmm. That I can take care here. Left view of the okay. Let's let's change this to something meaningful. Yeah. So let's call this as tree.
Mm-hmm.
Okay. So tree dot max level is equal to 0, and then tree dot left view of root, and level to be 1, and then uh, tree dot right view, but I want to ensure that this max level is initialized to 0 again.
Mm-hmm.
Okay. Now I don't want to pass root, but instead oh no, no, because I have taken care of right here itself. So yeah, level plus 1 should be suffice. Okay. So what would, where am I printing the data? So here, okay. So we go all the level, okay, so we go all the level down. So we print 1, and then, oh, okay. Max level is less than level. So by the time it reaches here, level would be 1, 2, 3, and 4.
Mm.
And so we are initializing max level to max at that time itself. So actually this won't work, because we are already initializing max level at 4. So every time, no matter it reaches level 3, level 2, or level 1,
Mm.
it would never get printed, because we have already initialized max level at 4. So all the time this condition will become false. Do you understand what I mean?
Yeah.
So okay. Actually, let's stick to the older approach itself, where we say we wanna print one, two, four, and one, and then uh, so one. Okay, we go one to four, one to four, and one. Okay, so that would still remain the same, and then the right subtree. So that would be one, um, three, eight, and eight. Okay, so we are good at right subtree, but
Mm-hmm.
not for the left subtree. So we just have to take the reverse of it.
Yeah.
So that would be one, four, two, and then one, and then combine three and eight here. Okay, man. Yeah. Okay. This is getting really complicated, but yeah, let's stick to the same plan. Let's move this code again back here. We don't want to change this. Okay, so same thing here. Okay. By the way, let me change this comment so I don't forget it next time. Yep. So this looks fine.
Okay.
Yep. So okay, let's try to see what's the output we are getting so far. Okay. So if I were to
Sure.
run this code, what is it giving me so far? Okay, awesome. So it is saying one, two looks good, and then 136. Awesome. Okay.
Yeah.
So this part is clear. All we just need to ensure is we are not passing the root here, right? So we
Mm-hmm.
just say root dot left. Boom.
Mm.
So it would be 2, 1, 3, and 6. I hope it works. Okay, awesome. So now our problem will not, like, our solution will not work because we wanted um, like go all the way go all the way to the left,
Yeah.
then traverse all the way to the root, and then start from root and print the right. So we don't have to change anything here. This looks absolutely good,
Mm-hmm.
except that when we are printing this data here, we want to reverse it. Do you
Yeah.
understand what I
Got it.
mean?
Got it.
Yeah,
Yeah.
right. So how do how do I do that? Okay, let's bring um, this
Bring
one
it
here.
back. Yeah.
Yeah, bring this back again and just say, oh, let me add this guy here because yeah. Okay, okay, let's comment this out for now
Mm-hmm.
and do okay. Let's keep this till like we just same thing here and same thing here again. Just okay. Now again comment this out and just paste this code in here. Okay. So hmm, okay. Now before I call before I call the right view, I just want to ensure one more thing. It's just that collections dot reverse of oops sorry reverse of list, yeah, and then I can just reuse this code here. Okay, and I'm just gonna say item. Okay, so yeah, so what it look like, how does the code look so far? Like just the same thing, except that before we pass this list to the right view, we just want
Mm-hmm.
to reverse this list.
Yeah.
So for example, if I have like 2, 4, and 1 printed, I will just have 1, 4, and 2,
Makes sense.
and then start from, I don't have to do that here because this one already works fine to me. So yeah. Okay, so let's see if this works. I think this will still give the same output. Oh yeah. So
Nice.
but but yeah, let's tweak this a bit. So 1, 2, 3, and then I want 4, 5, 7, and 8. Okay, so let me add some data in here. So I'm gonna say this as 4, and same thing here, but root dot right of 1, 2, 4, and 5,
Mm-hmm.
and copy this here, but this time right, right, and then left, and then right. Yeah, so root dot right of left and root dot right of right. Here it would be
Mm-hmm.
7 and 8.
Okay.
So 7 here and 8 here. So what's the output expectation? So it should be 4, 2, 1, and then 3 and 8.
4, 2, 1, 3, 8. Yes.
Okay, so let's give this a try.
Nice. Very cool.
So let's delete all the stuffs which are no longer required.
Okay.
Yeah.
Awesome. Yeah, I think this was great. I definitely threw you a hard one. So for the viewers, these are generally mock interviews, and Roshan just did fantastically in the mock part of it. So we decided to spice things up a little bit and throw this slightly more challenging variant of the question in there. You definitely, I threw a wrench into the process, and you wrangled that wrench and turned it into something fantastic. So this was great. What were your feelings about the interview?
Yeah, I mean, the left view looked pretty straightforward, but this one actually I haven't, like, frankly speaking, I haven't encountered such problems in my part. I mean, during my interview preparations.
Yeah.
So this was really, yeah, I'm actually feeling proud of myself. Like I'm able to solve it.
I think it should be, yeah. There have been a couple of times when I've been on on your end of the interaction and have had the same thing happen where I feel like this interview is going great and I'm 20 minutes into it and I've solved it, and then that just leaves more room for us to face more challenging questions, which isn't necessarily a bad thing. So that's something that I've been doing as an interviewer as well. It just helps get more signal from someone, and yeah, just even if people, my advice would be even if you don't get the right answer, we just want to see how you think. And you voiced out your thoughts throughout the whole process. Were very clear in what you were changing, why you were changing it, which definitely helps in getting signal, even if the end result isn't what the correct answer is, which in this case it was. So it was great.
Right. So just one thing, like for people who are, viewing this video right now, or whoever has an upcoming interview, I just wanted to help you guys understand that in case if you receive the question from the interviewer, like first thing that you guys need to do is ask enough clarifying questions. Like,
Mm-hmm.
as I started with asking, like if the root node would be null, or if we are only interested in binary tree or binary search tree, because anyways this will not change the output, but still it's always good that we ask clarifying questions. So that's the one thing which I improved over a period of time, and I would highly recommend people who are watching this video to ask clarifying questions and don't try directly jump into the solution and start coding int a equal to b or something like that. So once you have a thorough understanding of the question, then try to talk to the interviewer as much as possible, because one thing that you guys need to remember is that interviewer, I mean, the only person to whom you can talk right now is the interviewer, right? Like whatever is going through your mind, just talk through them. If like they are here only to help you out, they are not here to knock you off, or they don't have any ego issues. So they are here to select you. That's why you are attending the interview with them. So try to, whatever is going through your mind, just try to walk through them. So if you are, even if you are stuck somewhere, they will definitely give you some hints, and then you can progress further. And then once both of the parties are aligned to a solution or an algorithm, then I would recommend that you start coding.
Yeah, I think that's fantastic advice. Start with a verbal solution. That's the best. And you can get cues from the interviewer on whether you're on the right path, or just really iron out those kinks before you start getting code down. Yeah. Thanks so much, Roshan. This was fantastic. I'm very sorry that I put you on the spot, but also you really dealt with that fantastically. So thank you.
I was expecting from an FB engineer. Come on.
And good luck with your upcoming interviews.
Thanks so much for watching. Don't forget to hit the like and subscribe buttons below to let us know that this video was valuable for you. And of course, check out hundreds more videos just like this at tryexponent.com. Thanks for watching and good luck on your upcoming interview.